And we say that this is then linked to the impacts of climate change.
Could it be a crash with an asteroid of explosive proportions? Join us as we delve deep into the worst disaster, the mysteries of polar vortex.
Polar vortex is like a giant circling ice-cold whirlpool in the sky. But it's not just limited to Earth's north and south poles, it happens on other planets too. There are two kinds of polar vortex, one high up in the stratosphere and another closer to the ground in the troposphere. Imagine the stratospheric polar vortex as a high-altitude storm of superfast winds, usually found between 15 to 50 kilometers above the ground and mostly above the 50th parallel north or south. It's at its strongest during winter when the polar regions plunge into darkness, chilling rapidly as the temperature difference between the poles and the rest of the world grows. Fierce winds kick in, and the Coriolis effect, the Earth's spinning motion, gives it that whirling motion. On the other hand, the tropospheric polar vortex is a bit closer to home, happening in the lower part of the atmosphere. It's not as high-flying as its stratospheric sibling, but it still packs a punch. It has its own distinct size, structure, and seasonal patterns. Like its upper atmosphere counterpart, it plays a big role in shaping weather patterns, but it operates on a more day-to-day basis. These polar vortices aren't just cool scientific phenomena. They have a real impact on our weather, influencing everything from chilly snaps to massive storms. In spring, something exciting happens in the sky, known as the stratospheric polar vortex, start to weaken and break apart. The stratosphere is a layer above where we live, and it has its own kind of weather system, including this vortex, which is like a big spinning top of air. During winter, sometimes this spinning top suddenly warms up, causing the vortex to become less organized. This event, called sudden stratospheric warming, can shake things up in our weather down here on the ground. Moving down a bit lower, there's another vortex called the tropospheric polar vortex. This one is closer to us, starting from about 40 to 50 degrees north or south of the equator and stretching from the ground up to about 10 to 15 kilometers high. Unlike its upper-level counterpart, this vortex hangs around all year. Both vortexes are most potent in winter when the poles are at their coldest. People have been noticing these phenomena for quite some time. Scientists decrypted the tropospheric vortex was discovered way back in 1853, while the stratospheric one was discovered in 1952 with fancy weather balloons. But it's not just scientists who talk about these vortexes. This might have been mentioned in the news, especially during particularly chilly winters. For example, in 2013 to 2014, North America experienced a deep freeze, and the tropospheric vortex became a buzzword for explaining the bone-chilling temperature. More recently, in 2021, extreme cold in the central United States put the tropospheric vortex back in the spotlight. Since August 2023, a really cold air mass has been getting stronger and stronger. This buildup is important because it could cause some big changes in how the air moves around in the sky. These changes could affect the weather we get in winter, especially in places like the United States, Canada, Northern Europe, and Russia. The Arctic drama. The polar jet stream is like a fast-moving river of air high up in the sky, wrapping around the Earth near the poles. Imagine it as a winding ribbon of air acting as a protective barrier that holds back the polar vortex, which is a swirling mass of frigid air. Historically, this jet stream has played a vital role in keeping the polar vortex stable. But if the jet stream weakens significantly, it might fail to contain the polar vortex, causing it to collapse and release bitterly cold air into the northern hemisphere. This collapse would bring a surge of air, leading to an exceptionally cold winter. Understanding the polar vortex's consequences is essential for predicting and getting ready for the changes in the atmosphere that might happen in the upcoming months. The polar vortex is like a swirling icy storm in the sky. It happens when a big blob of super cold air forms in the polar regions during winter. This chilly air creates a high-pressure zone, which starts the vortex spinning. This icy whirlwind isn't just random. It's influenced by lots of things happening in the atmosphere. One cool thing about the polar vortex is how it spins. It's not just twirling aimlessly, it's following a dance routine set by the Earth's spin. In the northern part of the world, things often get pushed to the right, while in the southern part, they get nudged to the left. Imagine a giant swirl of air called the polar vortex spinning above the North Pole, moving counterclockwise, and another one around the South Pole spinning clockwise. These swirling masses of air are like huge donuts encircled by strong winds called jet streams. One of the most important jet streams is the polar jet stream, which acts like a fence separating the cold air inside the vortex from the warmer air in the middle parts of the world. This keeps the cold air from spreading too far southward. The way the polar vortex and these jet streams dance together is fascinating. This collapse happens when there's a big difference in temperature and pressure between the equator and the poles because of how the Earth spins. Sunlight isn't spread evenly. This makes the air above the equator warmer, creating an area of low pressure, while the air above the poles is colder, making a high-pressure zone. Ballet of air currents and jet streams. The temperature differences push the chilly air from the polar vortex to move toward the warmer areas near the equator where there's more room. It's like a constant battle between these weather systems caused by temperature changes, and this battle makes the polar vortex weaker and more at risk. The weaker the polar jet stream, which is like a fast-moving river of air in the atmosphere, the more likely the polar vortex is to collapse. If the jet stream loses its strength, it's like removing a barrier, messing up normal weather, and even potentially causing a collapse. And these collapses aren't just something scientists talk about, they happen fairly often. It's like a regular event in Earth's climate system, not some rare occurrence. When the polar vortex gets disrupted, it messes with the weather, especially in winter. And these collapses happen every so often. Additionally, the collapses of the polar vortex possess a fascinating array of intricacies and effects. When the polar vortex weakens or splits, it's similar to a giant atmospheric engine stuttering or momentarily malfunctioning. Others unleash a cascade of dramatic consequences. Consider the infamous Great Blizzard of 1899. This monumental storm wasn't just a run-of-the-mill snow day, it was a meteorological monster that gripped the United States with an icy fist. Temperatures plummeted to bone-chilling lows, and snow piled up in towering drifts, bringing life to a standstill. Fast forward to December 2012 and January 2013 when another polar vortex collapse shook the world. Triggered by a sudden stratospheric warming event, this atmospheric upheaval unleashed a relentless onslaught of snow and cold across the tri-state area and sent shivers down the spines of Britons with its frigid onslaught. Airports resembled ghost towns, and the relentless cold seemed to seep into every nook and cranny. These polar vortex disruptions aren't just fleeting moments of meteorological drama, this is exactly what's happening now. Observations show that the vortex is getting much stronger as winter progresses. In early 2023, they received an early confirmation, which gave them important information to watch and study the path and actions of the polar vortex in the next few months. This confirmation acts as a starting point for continuous evaluations and forecasts, helping scientists enhance their knowledge about the vortex's traits and any potential deviations from normal patterns. Work is already in progress to predict and prepare for the atmospheric changes related to the polar vortex. Recent observations have sparked concern. There's a noticeable weakening trend in the polar jet stream, which is worrying because it might struggle to keep up its protective role. This weakening trend hints at the frightening possibility of a complete breakdown. The consequences of such a breakdown are terrifying, especially as the Western world is already facing an energy crisis and insufficient building insulation. A powerful blast of freezing air is on its way to the northern hemisphere, promising an extraordinary winter experience across the region.